You're listening to Life, the Universe, and Everything Else. Today on the show, we talk about ancient scientific discoveries.
Life, the Universe, and Everything Else explores issues of science, critical thinking, and secular humanism. If you have questions or comments about the show, or you'd like to suggest a topic, you can find us on Twitter or Facebook, or send us an email at lueepodcast@winnipegskeptics.com. Show notes and references can be found at lueepodcast.com.
My name is Jem Newman, and with me today I have Ashlyn Noble.
Hello.
Lauren Bailey.
Hello.
And Laura Creek-Newman.
Hi there.
Before we get started, Lauren has an important message about Skepticamp.
Hey folks in the Winnipeg and surrounding areas. This is your final reminder that we are again hosting Skepticamp on September 16 at the St. Boniface Library. Topics include non-rational aspects of the human mind and a deep dive into Mormon doctrine. We'll also be doing a live recording of LUEE with the Revenge of the Quiz Show! This time with 100% more audience participation. We will get started at 11 a.m. and, while admission is free, we will be hosting a bake sale to help pay for website hosting. So see you on the 16th.
On our last episode, we talked about a number of scientists, theologians, and philosophers who were labeled heretics for their academic pursuits. And they all happen to be European? Well, most of them anyway. You could argue that Hypatia wasn't really Greek, but Egyptian, though the idea of national or ethnic identities were fairly fluid at the time, and Egypt was a Greek territory. Hypatia was European adjacent at the very least. Anyway, this month, I'd like to take a less Eurocentric view and discuss some important scientific, technological, and mathematical discoveries made in the ancient world outside of Europe. I'm going to start us off today with the magnetic compass. Just to make sure everybody's on the same page, I probably don't have to describe what a compass looks like to most people, but what the hell, I'm going to anyway. Hey, this episode I get to geek out about magnetism. I'm taking full advantage. So at its simplest, most people can picture a compass. It's a housing, usually circular, with a needle or other pointing device suspended in it such that it can spin freely to point in any direction along a horizontal plane. Who can tell me what a magnetic compass does?
Points north? Points to magnetic north?
Yeah. It points toward the North Magnetic Pole, or magnetic north, as Ashlyn said. And what is the magnetic North Pole?
Up there somewhere, where all the metal is.
It's a magnetic mountain.
It's not the same as the other North Pole.
My phone has a compass.
Yeah. So for all of our younger listeners who've never seen a compass, just pull out your iPhone and open the Compass app.
You'll probably have stored it in the area of unused apple crap.
Yeah, I have a folder called apple crap.
So the North Magnetic Pole is the point at which the planet's magnetic field lines point straight down into the Earth. It is important to distinguish, both for us and for people using compasses, the geographic poles from the magnetic poles. The geographic poles are the antipodal points that describe the location of the Earth's axis of rotation. So if you imagine a line being drawn between the North Pole and the South Pole, the Earth spins along that axis. In most of the world, if you look up at the sky as the Earth rotates, you'll see the sun and the other stars rise and set. If you're standing on a geographic pole and you look up at the sky, the stars don't rise and set, but simply spin above you. Also, you'll probably be pretty cold, so wear a jacket or something. The location of the magnetic poles don't actually correspond to the location of the geographic poles, but at least right now, they're pretty close. In addition to the geographic and magnetic poles, we can also talk about Earth's geomagnetic poles, but we're not going to. Here's a question. Does the compass always point in the same direction?
No.
No? Depending on where you are on the Earth?
Does it always point toward the same location on Earth?
Well, doesn't the magnetic North Pole move around?
In 2001, the Geological Survey of Canada determined that the magnetic North Pole was located just off of Ellesmere Island in northern Canada. But by 2009, while it still fell within the Canadian Arctic territorial claim, it was actually moving toward Russia at about 60 kilometers per year.
Just like Trump.
It's a good joke. And as of this year, it is projected to no longer fall within Canadian Arctic territory. So why is this happening? Well, the Earth's magnetic field is generated by the motion of molten iron in the Earth's outer core. This model is known as dynamo theory, and it also explains the observed fact that while magnetic north generally remains fairly close to geographic north, the location of the magnetic poles wander slowly over time. And sometimes, not so slowly.
They flip.
Every 500,000 years or so, the Earth's magnetic field enters a period of instability and then undergoes a magnetic field reversal. This actually hasn't happened since the invention of the compass, but there is geological evidence attesting to it, and NASA has modeled the process. During a reversal, which actually occurs pretty slowly over a period of a few thousand years, the Earth's magnetic field is disrupted, and many different north and south magnetic poles exist on Earth simultaneously. If a magnetic reversal began today, we would see compasses in different parts of the world slowly diverge from each other over hundreds of years to point in completely different directions, before eventually settling down to point in the opposite of the direction we're used to. The most recent known geomagnetic reversal, called the Last Champ event, was actually a fairly strange one as far as these things go. It happened only 41,000 years ago during the last glacial period, but unlike a typical reversal, it only lasted a few hundred years instead of, a few 100,000. Brief disruptions like this, known as geomagnetic excursions, very rarely result in a complete reversal like this. Prior to the Last Champ event, the most recent complete reversal was the Brunhes-Matuyama reversal, which was 780,000 years ago.
So we're due and we're all gonna die.
See, it seems like it. No, we're not all going to die, but it will be disruptive.
Will that be what sets off Yellowstone?
NASA's gonna drill into it because it needs to be.
We gotta lance it?
Yeah.
Basically, the comment I saw was, I've seen this movie.
I'll put this as simply as I can. Everybody on Earth is dead in a year.
The core of the Earth has stopped spinning.
We need you to control the flow of information.
You want me to hack the planet?
Okay, so that's enough geeking out about magnetism in the abstract. Let's talk about how a magnetic compass actually works. So the compass needle is magnetized, meaning it becomes, essentially, a magnet. Early compasses were made of lodestone, which is a naturally magnetized form of magnetite, which is an iron ore. The word lodestone, incidentally, comes from Middle English, and it means leading stone or journey stone. Later compasses, instead of using lodestone, used iron needles that were themselves magnetized by repeatedly bashing them with lodestone.
Transferal properties of magnets.
Smashy.
So when a magnetized needle is suspended such that it can turn freely, which was originally done in water, the magnetic needle will attempt to orient itself to the local magnetic meridian. If there are no stronger magnetic fields nearby, the north pole of the needle, which is often painted red, will be drawn toward the north magnetic pole, and the south point of the needle, often painted white, will be drawn toward the south magnetic pole. As I'm sure many of our listeners are aware, however, it's fairly easy to override a compass with a magnet that is either close enough or strong enough. In this case, preferably close enough, given that the strength of the field falls off quickly according to the inverse square law. Interesting sidebar.
No.
So remember how at the top of the segment I said that at the north magnetic pole, the field lines point straight down into the Earth? That's because when you're looking at magnetic fields, the field lines enter one pole of the magnet and then emerge from the other. If you look up any diagram of this, it'll look kind of like a torus. Yeah.
We all know how magical those are.
Yeah. Take a look at our, what was that, resonance beings of frequency?
Yeah, the least sensible
we
title.
definitely talked about that there, but I think there was actually an earlier pseudo-documentary that talked about the magic toruses.
Super bizarre. Anyway.
So the field lines, when you visualize them, it looks like a donut on its side, like a diagram of a warp field. I'm getting off track.
Reorient your compass, Jim.
When you're looking at magnetic fields, the field lines exit from one pole of the magnet, loop around, and then enter the other pole of the magnet. However, the directionality of magnetic fields are actually defined such that the magnetic field lines emerge from the north pole of the magnet and enter the south pole of the magnet. This means that, technically, the magnetic pole closest to the north geographic pole is actually the south magnetic pole. But it's the one that the north pole of magnetic materials, like compass needles, like to point to, at least until the next magnetic reversal. Just bringing up this whole the northern magnetic pole is actually magnetic south thing puts you in dangerously pedantic territory. I'd recommend against it. It's like responding to the question, what's your favorite berry, with green pepper, or insisting that the plural of octopus is octopodes.
Pretty much any conversation with you.
It's technically accurate, but also technically insufferable.
Just like any conversation.
You are technically correct. The best kind of correct.
I can't believe this is where we've gotten to on a discussion of the discovery of the magnetic compass.
Really? You can't believe this?
This is bad even for Jem.
Oh, God.
Why do I get into this? Probably because deep down I'm convinced that I don't deserve friends and I'm trying to drive them away. Let's get back to the compass itself. The compass is one of China's 4 great inventions. These are 4 discoveries that shaped the development of civilization in China and around the world.
Was one of them fireworks? Gunpowder.
I was going to ask if anyone wants to take a stab at the other 3. So we have gunpowder.
Paper.
And what is the last one?
Kung Pao chicken.
Pretty sure I've mentioned it at least in passing on the show. We have the compass, gunpowder, paper making, and woodblock printing.
I was going to say something about printing. I'm like, no, that's not right. Damn.
Yep.
The one I've actually done.
Francis Bacon, writing in the early 17th century, claimed that these inventions, quote, altered the face and state of the world. Though in Bacon's time it was Europe rather than China that was commonly credited with the discovery of these 4 great inventions. So why is the compass so important?
Being able to find your way when there's no stars and stuff?
That is it exactly. Prior to its invention, navigation was typically done by landmark, with the sun and or other stars providing directional information when far from land or when in unknown locales. The compass allows an explorer to ascertain their direction during cloudy or foggy days, when landmarks are difficult to discern and or when the sun and stars can't be seen. So with this in mind, how do you think the earliest magnetic compasses were used?
Yeah, I don't understand the question. To find your way.
I'm afraid that's incorrect. Records from the early Han Dynasty, circa 206 BCE, provide the earliest known references to a magnetic compass. But we actually don't see solid evidence for use in navigation. Instead, it appears that the compass may have been used for divination. In The Fundamentals of Geophysics, William Lowry writes, quote, "The compass may have been used in the search for gems and the selection of sites for houses." It wasn't until the Song Dynasty of the 11th century, more than 1,200 years later, that the navigational compass came into use for military wayfinding in China. In 1119 CE, author and maritime expert Zhu Yu recalled the proficiency with which sailors navigated the seas. Quote, "The ship's pilots are acquainted with the configuration of the coasts. At night, they steer by the stars, and in the daytime, by the sun. In dark weather, they look at the south-pointing needle." Did you notice what Zhu Yu called the compass? It was also called the South Governor. The traditional Chinese compasses actually pointed south rather than north, but remember that the magnet is just orienting itself to be parallel to the direction of the magnetic field lines, so it will have a north side and a south side. Which of these two is the direction in which it is pointing is a matter of perspective, or more often, paint. But the primacy of south over north in this case is at least interesting.
Well, that would make sense for their military exploits, because if you look at China's coastline, it's more on the southern half of the country.
In my research, I did encounter references to earlier claims of magnetized needles being used in China for navigation, but they were difficult to track down to reliable sources. But even discarding all questionable sources, the use of the compass in China for navigational orienteering predates that of Western Europe and the Islamic world by hundreds of years. The compass still plays a prominent role in not only navigation, but Chinese mysticism. The LUEE, or geomantic compass, is still used today by feng shui practitioners to orient buildings in an auspicious manner, promoting harmony and good luck. The needle of the luo pan is surrounded by dozens of concentric rings, in some cases as many as 40, and these rings together are known as the heaven dial, and it is inscribed with feng shui formulae. I would like to end this segment by encouraging everyone to try to make their own compass, because it's actually pretty easy. So right here in front of me, I have got a cork. I'm just going to cut a small piece of cork right here. I'm going to do some live science, and if it doesn't work, I promise not to hide it in a file drawer.
This is great for radio, Jim.
Girl Guides, we always learned to do this with a leaf in water.
Oh, yeah?
Like put the needle on a leaf?
Yep.
Neat. So all I've done here is cut a small slice of cork so that I have a floating medium on which to place my needle. So you need a piece of cork, a piece of ferromagnetic material, so a sewing needle is what I've used here, a bowl of water, and something to magnetize the needle. So I used a fridge magnet, but most anything that can generate static electricity can be used as well, like a piece of fur or even just your own hair. Magnetize the needle by moving it repeatedly in a single direction, not back and forth. It'll probably take several dozen attempts before the needle is sufficiently magnetized. And then you can just push the needle through the center of the piece of cork and place it in the water so that it floats, and it should slowly turn to orient itself vaguely north-south.
Okay, now
Is it working?
Can we compare with our iPhone compasses?
Yeah, let's do it. So it's pointing in that direction.
Kinda agrees.
So this is actually interesting because the iPhone is almost certainly doing a directional correction for magnetic north based on your geographic location. It looks like they're off by about 15 degrees.
I mean, you'd still be heading north-ish if you followed it.
It will be subject to all sorts of currents and winds, so this works best inside in a relatively small bowl.
Well, I was wondering if there was like a setting that I could do to make it go to magnetic north instead of using my location. Oh, here. Use true north. On or off.
Was it on?
Boop. No, I'll turn it on now and then we'll go look.
Is your computer throwing it off or something?
So before it was using magnetic north,
Yeah.
I assume.
And I'll post a picture of this in the show notes if I remember. And if I don't, oh well.
You can look it up online.
Next, Lauren is going to tell us all about the number 0.
It's a number. It's a concept. Because nothing is worth so much. Which is the title of my segment.
I like that you titled your segments.
I always title my segments.
I didn't know that.
Yeah.
That's fabulous.
And if I'm really impressed with them, I'll say them during the segment. And if I'm not really impressed, then I won't.
Okay.
But coming into the research for this segment, I had some vague notions about the concept of 0. I mean, I know what 0 is. I knew it was the youngest of the natural numbers, because it's a difficult concept to work your mind around if you aren't in the mindset of thinking about the absence of something as being a property of that thing. I also thought that the credit for the discovery of 0 belonged to the Arabic world. It made sense to me. We use Arabic numerals, and the 0 we know belongs to that set. Well, I was right on the first point, and wrong on the second. Most credible accounts point to India as the birthplace of 0. And the name of the numeral system is Hindu Arabic, which I did not know. There's also evidence that 0 was discovered independently by multiple cultures around the world, but only as a placeholder and not as an independent concept. The Sumerians were the first people to develop a codified counting system between 4,000 and 5,000 years ago. This system helped beget the positional Babylonian numeral system, a base 60 positional system that also shows influence from Semitic languages. There are more twists and turns, but that is another whole podcast episode in itself. Would folks be interested in doing a History of Numbers episode, Jem? This might just be a you and me kind of thing.
Sounds fascinating to me.
Anyway, back to Babylon. Its base 60 system survives today in our 60-second minutes, our 60-minute hours, our 360-degree circles, and 60-degree equilateral triangles. A positional numerical system is one where each number relates to the ones around it. The most common surviving positional system is Roman numerals. The Babylonian system had a symbol that sort of looked like a point-down triangle on a stick, and that represented 1. A second point-down triangle on a stick beside it represented 2. Unlike Roman numerals, there was no special symbol for 5, so you stacked these sticky triangles into an octothorpish thing to represent 9. 10 in the Babylonian system is represented by a symbol that kind of looks like a B-2 stealth bomber facing to the left.
Von Daniken was right.
Yes.
Von Daniken was right. It's proof.
Yes. None of them were right. So 2 stealth bombers meant...
20?
Yes! While the Babylonians understood the concept of nothingness, they did not have a separate symbol for it. After expanding their base 60 to get larger numbers, what would to us be a 0 in any column was represented by a placeholder. It looked like 2 of the sticky triangles rotated 45 degrees and written as superscript, so it was smaller and above the line. And this eventually morphed into 2 angled wedges. Across the globe, the Mayans also used a form of 0 as a placeholder, while not recognizing it as an actual number. Their symbol looked like an I. While it appears that the Mayans invented their 0 from scratch, which is an amazing feat in and of itself, they did not use it in calculations or in any significant way. So where does India come in? Well, right here, thanks for asking. There's 2 schools of thought surrounding the creation of 0 as its own number. The first school is that the Babylonian concept of 0 came through the ages and was refined in India. The second school is that the concept was developed independently in India. The 0 Project, which was developed to study the discovery of 0 in India, and is also available in the show notes, believes that 0 comes from the concept of emptiness, or sunyata. The Sanskrit word for mathematical 0 is shunya, which has the same root. The concept of 0 first appeared in India around AD 458 when mathematician and astronomer Aryabhata stated, "From place to place, each is 10 times the preceding," which is the origin of the modern decimal place value notation. 0 was then defined by the Hindu astronomer and mathematician Brahmagupta in 628, though he does not claim to have invented 0, only a symbol to represent it. He speaks of it as if it is a known concept at this time. So while he didn't invent 0, Brahmagupta developed mathematical operations around it, from addition to subtraction to more complex equations, cementing its status as a number and as a concept.
So we're talking things like 4 minus 4 equals 0.
Yeah.
4 plus 0 equals 4, etc. Okay.
The decimal system of numbers as we know it today, instead of positional systems, relies on the existence of 0, both as the standalone and as part of the whole set. Using 0, humans were able to develop equations that led to calculus and basically the entire modern world. Short and sweet.
Yeah, it was hard when I was first learning about the distinction between a placeholder numeral versus a number in and of itself, what that distinction was.
Oh my god, it's so hard. As we know 0, we can't think of a world without 0.
Yeah.
Right.
It may be more confusing that we use the same symbol for both in some senses, because a placeholder number allows us to just, when you're counting, say 1 to 9, you use a different numeral for each thing in a single place, and then when you count up to 10, you're just reusing the numeral 1, but shifting it over a place, and the 0 just holds that place. It says, hey, there is something here. The 0 basically tells you where the decimal point goes.
Yeah, and that is the
sense.
entire decimal system of numbers. And it couldn't have been invented without a 0.
Exactly.
Otherwise, you end up with B-52 stealth bombers facing left.
So the zeros are just padding in that case. And if you've ever studied scientific notation and the way you talk about significant figures, 0 actually becomes contentious in some ways.
And you still can't divide by it.
Sure, you can divide by 0, you just get infinity.
No, you get error.
Well, 0 divided by 0 is nan. Anything else divided by 0 is infinity.
Well, Jen solved that for us. Wow.
It's implementation dependent. But 0 as a number by itself, as a quantity, is very important for mathematics, obviously, and it is so fundamental to the work that I do on a daily basis that it's one of those things that's hard to remember that it had to be invented.
Otherwise, we'd just have one. We'd have unary system.
Oh, God.
It's difficult for me to wrap my brain around base 60 and base 8 mathematical systems because we were raised so much in the decimal system. I can't think of how you would deal with a base 60.
So that's interesting. Most people think, how could you remember all of those different numerals? We do that all the time, though.
Yeah.
Like, when you sort something alphabetically, you are sorting numbers in a base 26 system.
Right, or base
But
whatever
that's way harder
system.
than counting to
So which name comes first alphabetically, Lauren or Laura?
Laura.
Laura.
Yeah. You just determined which number is higher in a base 26 system. We can actually do it in our minds, and actually learning about bases
Well, no, but
and...
wouldn't Lauren be higher because it has more numbers?
No.
So it depends where the decimal point is. Numbers and words kind of count up. One counts to the left, one counts to the right, depending on how you look at it. But which one is higher or lower it's academic.
That's not the problem I have with different base systems. It's just the actual theory of wrapping my brain around it. I can do it if I think about it, but the thought that people don't use a base... Like, how do people use imperial measurement units?
So actually, base 12... which is where we get dozens, etc., is actually, for basic arithmetic, and I may have mentioned this before on the show, is actually better in a lot of ways. Because when you have base 12, it's much easier to learn multiplication and division in a lot of different ways. In base 10, if you want to divide 10 or 100 or whatever into different pieces, you end up getting fractions a lot more quickly.
Yeah.
In base 12, you can divide 12 in half to get 6. You can divide it in thirds to get 4. You can divide it in quarters, but you can divide it by 4 to get 3. You can divide it into 12s to get 1.
Well, that's why the Babylonians had the base 60, because 60 was like a perfect number.
Exactly.
Because it had so many exponentials.
So there are lots of advantages to different systems that are non-10 based. And there are disadvantages too. One of the classic problems of binary is the fact that there's actually no good way to represent 0.1 in binary.
There's not.
And people are like, well, that's such a fundamental thing. Like, how can you use a system where there's no good representation of 0.1? And in fact, lots of programming languages have to cheat because it's a very common thing to want to represent. They optimize around that. So that seems weird, but our system has no good way to represent 1/3. Binary doesn't have a great way to represent 1/10. Our system doesn't have a great way to represent 1/3 or 1/9 or 1/7 or lots of basic fractions. And people just forget that.
0.33333 to infinity.
Yeah.
I run into this because I run our lotto group at work. Yes, I know lotto. But there's 6 people in our lotto group, so it always divides into 0.66666 to infinity. So I just end up giving myself 0.67. Screw it, they can give me a penny.
Actually learning about bases and the way the base system works is kind of like learning about English grammar for the first time when in school you learn what a verb and noun and what the various parts of speech are. It is mind expanding in a way that I didn't expect. So I'd highly recommend... Maybe we'll do a podcast episode about base systems at some point because
Well, that's what I was talking about.
love this
Let's
stuff.
do one about numeracy.
Tim, this has to be on your own personal podcast.
Okay.
So let's drop the bass.
Thank you for that short and sweet segment, Lauren. I'm sorry. I'm sorry I made it so long.
It's okay, you're just going to mansplain 0 at me. It's not like I did any research for this or anything.
Jim wanted to do 0 and Lauren took it, so
Yeah.
he had to get his say in anyway.
No, I appreciate the other insight.
Do you know where Saskatchewan is? Probably not. It's in Canada. If you do, you might know a city named Regina. In Regina, there's a studio. And in that studio, there are, at least once a month, a bunch of skeptical atheist geeks and goofballs who get together to do a podcast. We are the Brainstorm crew, and we're trying to help spread a bit of reason and critical thinking while still having fun. Never taking things too seriously, but still not accepting everything we're told. We go through different topics, exploring them in depth, and often disagreeing. We try to stick to provable facts, and we never trust in myth. That's why we say we're woo-free since 2013. You can find us on iTunes, Stitcher, or Spreaker under Brainstorm, or check out our website, brainstormblog.net. I can't promise you'll always agree with us, but I can promise you'll have fun listening to us.
From 0, we're going to move to the ancient Arabic world, and Laura is going to tell us all about Muhammad ibn Musa al-Khwarizmi.
All right, so Al-Khwarizmi followed the invention or the discovery of 0 by a few hundred years. So he lived in the 9th century CE. He was of Persian descent. He was born in what is now Uzbekistan. And he worked and studied primarily in Baghdad. So about this time, We are approximately 100, 200 years after the beginning of the Islamic Empire, and Baghdad was really a center of arts and culture and learning. And particularly the Caliph at the time really wanted to bring prestige and culture and learning and scholarly works to the Islamic world. The main center of the scientific knowledge and research there was a place called the House of Wisdom, and that's really where everyone who was anyone was located. And it wasn't just people of Middle Eastern descent. People from all over the place were actually coming here, and some of them were coming from places like Greece, where at that time scientific discovery and learning was perhaps more frowned upon by certain ruling groups and so they found refuge and were actively called to the House of Wisdom in Baghdad.
They didn't screw around with names, huh? Just like, this is the House of Wisdom.
Yeah, I'm pretty impressed.
Next door is the House of Pancakes.
Both good things. And when you spend a lot of time doing wisdom, you need a lot of pancakes. Like, they just go hand in hand, right? So that is where Al-Khwarizmi was located. And the majority of his work was produced between 810 to 830 CE. As many scholars of the time, he wasn't working in just one area. Of course, he was a scholar in mathematics, astronomy, and geography, and he did a lot of translation as well. At this time, too, the Caliph Al-Mamun was his patron, and Al-Khwarizmi worked very closely on a lot of projects, including a very large and detailed map of the known world at the time. So I had never heard of Al-Khwarizmi before I started doing research, but truth be told, I don't know a lot about ancient scientific discoveries of any background. That's just not something that I've done a lot of research in. However, when you do start looking into it, his name comes up over and over and over again. Mm-hmm. And that is why I thought that I would go for him. And even more so when I was, from the last episode, I had looked into Roger Bacon and what he had done. Al-Khwarizmi was one of the big influences for people like him. So when we hear things like, oh, the Europeans wanted to draw on Arabic knowledge, Al-Khwarizmi, his works was one of the big sources that the Western Europeans brought into their knowledge and learnings.
And that's how we got bacon at the House of Pancakes.
It's a natural pairing there. So he produced, like I said, many major works, the most important of which is that he is considered the father of algebra. His major work is called the Compendious Book on Calculation by Completion and Balancing.
It's such a wonderful name.
All of the names of his works are wonderful. They are just descriptive and flowery and just fantastic. Well, there are different forms of algebra that had existed for several centuries prior to Al-Khwarizmi. His differed from those because his was the first to describe a general way of discussing and solving mathematical constructs. Previously, those types of problems were more specific problems, and for example, an equation may come out of the description of the problem, but it was very situation specific, so everything was very individualized, whereas his system was very generalizable. So you start with equations that can then be applied to different problems in different categories. And he was the first one to determine not just that you start with equations, but outline what types of equations there were. So he laid out the process for doing linear and quadratic equations, which was quite impressive at the time. No one had really done that. So he would describe things like an equation, 2x squared equals 10x plus 5. So he was the first one to describe an equation like that. What's really interesting to note, though, is that they didn't yet use notation for this or use symbols or characters. So in his treatise there, he used full words, including the words for the numbers, to describe how equations worked.
My eyes are crossing just thinking about
that. They have there's little excerpts in some of my references, and it's beautiful language. It's actually quite lovely, but it's because it's lovely and voluminous, it's very easy to get lost in things. But think about how many words it would take to describe 2x squared equals 10x plus 5. That's actually a lot. And then to describe what to do with that and what that means. So from him, we get the concept of restoration and completion. So the completion and balancing, that the name of his work comes from. And the Arabic word at the time for that completion was al-jabr, which is where we get algebra from. That concept is the one where we add or subtract a number to both sides in order to resolve and simplify an equation to solve for x. So we start moving like things to the same side. Again, you balance the equation and you simplify it, and that's his process. While we use algebra we used it for the beginnings of many, many complicated things for a long time, the reason that he determined it is that he actually wanted a very generalizable and practical way to solve everyday problems that people living in the Islamic world were dealing with, particularly for dealing with inheritances and all sorts of things where you'd have to divide wealth or products in different ways according to Islamic law. So he wanted to devise a system that you could do that easily and not have case specific.
So in 10 years, when Kira says, I will never use this algebra again, you can use this as a...
When Mommy and Daddy are dead, we'll need to divide our possessions.
and solve for X.
Yeah. Yeah, Daddy will write that into his will, I'm sure. So that is the major work that he is known for. And his books on this were used up until the 17th century as the standard text on how to do these kinds of things. So that is a huge influence. Other major works that he is responsible for is he introduced the Hindu-Arabic numeral system that Lauren discussed to the Islamic world and Islamic scholars. He was a big proponent. So obviously he didn't discover it or anything, but through his research he found it and he said, guys, this is what we need to be using. And it was through his influence in the Islamic world that it was then ported to the Western European world as well.
Yeah, because the Western Islamic notation is much easier than the Eastern Islamic notation. The Western one is the one we know.
Right.
The Eastern one has got some curly cues and dots.
Yeah, I was looking at a chart and it goes through what they would call the Hindu-Arabic notation systems, and it had everything from the standard Arabic numerals that we are accustomed to all the way into like several different Indian language variants. And some of them in the middle were more the Eastern Arabic ones. And I found it very confusing because some of them were like, oh yes, that looks like a 2. That looks like a 3. Wait a minute, that 4 does not look like a 4. But now the 5 looks like a 4. Uh-oh. Oh, I'm so confused now.
Looks like a 6. We were looking at the same chart.
Yes, exactly. So I'm like, okay, I get this. Oh, I would get lost so fast. But it is largely because of his efforts that we really adopted that system and continued to use it. So that's the 0 to 9 system, as Lauren had mentioned. Although he, I think, was using 0 as a placeholder. I don't think, from what I read, I don't know that he was fully understanding the concept of 0 at that point.
It's hard for me to believe that he didn't understand 0 as a concept if you're balancing equations, because at some point you're going to end up with a 0 on one side.
Right, I don't know. I might have misinterpreted that. The other thing that he did is that he described how to use the Arabic numeral system because he knew that that's what people would need in order to adopt this. And so this technique and arithmetic that he wrote about was termed algorithm or algorithm. And that was the Latinized version of his name. The Latinized version of his name was Al-Khwarizmi. So algorithms, Al-Khwarizmi.
Never heard of him.
As many other people of his time, he also did a fair amount of work in astronomy. He developed, some will say, hundreds of charts and tables that chart the sun's movements, as well as those of the moon and the 5 known planets at the time. And he also expressed these as sine and tangent values. He worked on various calendars and prediction of different dates within those calendars. And what's most notable for him here is that he was one of the first Islamic scholars to produce new works in this field. At this point, a lot of the Islamic scholars were researching and studying what was already known, but they weren't producing their own and doing their own research and that. So he really started that trend for them.
They were really into sort of studying the Greek and Roman stuff and
Indian too.
Okay.
They were really following the Indian astronomy because the Indians had done a lot of the first work, and so they were studying that. But he was really what started getting the Islamic scholars doing their own work. And then lastly, he actually did a fair amount of work on geography as well. So he improved Ptolemy's map of the known world at the time, and he identified and listed the coordinates of over 2,000 sites, including cities and mountains and rivers and lakes, with a greater precision than Ptolemy had. And his coordinates could be used to produce one of the most accurate maps of the known world to them at that time. And the Caliph at the time had him use his geography skills to produce the massive map. So we can go into a lot more detail on him, but he is really one of the great, great thinkers of the time. And when we think about or hear about, the Arabic scholars that influenced the Europeans, he is definitely one of them.
Thanks, Laura.
What happens when you're an atheist living in the Canadian Bible Belt? If you're like me, you gather some friends and you take to the airwaves. So I invite you to come and join us every week to take a left to the valley and find out where you stand in this world. Follow us on iTunes, YouTube, Spreaker, Blog Talk Radio, or SoundCloud, or lefttothevalley.com. Atheist, skeptic, and humanist radio, no God required.
Now we're going to turn to Ashlyn, who will tell us all about glass? I don't know. What's your segment about, Ashlyn?
Yeah, I didn't tell anybody what I was doing. I originally had a different topic, and then I sent Jem my show notes, and was like, by the way, I picked a totally different topic. Okay, so Jabir ibn Hayyan was probably an 8th century polymath who wrote upwards of 3,000 works on many topics, including alchemy, medicine, and astronomy. He overlapped the guy Laura talked about by a few years. He died in 812. And like him, he was one of those people who sort of got his hands in everything, and a lot of his work still survive today and influenced a lot of people for a long time. I say he probably was because as early as the 10th century, people were questioning whether all the stuff attributed to him was really written by him, and then if he even existed at all.
So there's more evidence for him than for Shakespeare.
Oh god, let's not get into the Shakespeare thing.
Shakespeare existed, he wrote his own plays.
Yep.
While many of the things initially attributed to him were probably written by his followers, there is quite a bit of evidence that he did in fact exist. And his name is often Latinized as Geber, Geber, instead of Jabir. So Jabir was big into alchemy, and his texts were used as alchemy and chemistry textbooks in universities up until like the 14th century. Unfortunately, he was also big into gatekeeping alchemy, so the stuff he wrote was in such jargony, coded language that only someone who had been initiated into his alchemical school could understand him. It is sometimes hard to tell what he meant to be taken at face value, and what was an elaborate allegory. The Wikipedia article on Jabir says that the word gibberish may have originally referred to his writings, but I couldn't find another source on that, so take it with a grain of salt.
Is that why alchemy doesn't actually work? Because we haven't just figured out his code?
No. He is credited with being the first person to describe many compounds, especially acids, including citric acid, sulfuric acid, acetic acid, and things like arsenic and mercury. He was also the first to describe processes, so crystallization, distillation, lots of stuff that's really key to chemistry. He is sometimes called the father of early chemistry, although he was also really interested in artificial creation of life and had recipes in his work for making scorpions, snakes, and humans in the lab.
It's alive!
So there was still a ways to go with his understanding of the topic. That was the sort of the focus of a lot of his alchemical work, was how to create life in the lab. Recipes for making in vitro humans, way before his time.
I have a recipe for making in vivo humans.
He made the first known examples of the alembic and the retort, both of which aid in distillation. So the alembic is kind of a still, and the retort, if you think of like weird old-timey chemistry components, it's sort of like a kidney-shaped thing with a long neck that points down. And so if you heat something in it, it will condense in the neck and drip down. And so he was apparently the guy who figured that out. He was also the first to combine ammonium chloride and nitric acid to produce aqua regia, royal water, so named because it will dissolve gold and platinum. This was considered a major step forward in alchemy at the time, although I don't think they ever figured out the whole lead into gold thing.
No, but we can turn gold into water.
Yeah. It's now used in etching, cleaning glassware, and refining gold, so the process that you use if you want to make 99.999% pure gold. It was also used to dissolve the Nobel Prize medals from 2 scientists who were in Nazi Germany who weren't allowed to accept their prizes. They dissolved them in aqua regia and then they put them on a shelf. And when the Nazis came and ransacked their lab. It was just like on the wall of chemicals. And after the war, they took this jar and precipitated the gold out and then had the Swedish Institute recast them into metals.
That is awesome.
That's hilarious. Hiding in plain sight at its finest.
Refinedest.
So Ibn Hayyan was the guy who came up with Aqua Regia. Of most interest to me, however, was his work entitled Kitab al-Dura al-Maknuna, the Book of the Hidden Pearl, in which he described 46 precise recipes for colored glass. So he figured out a whole bunch of different ways to make cool colors in glass, and he actually wrote them down, which was a big deal.
That's what he did with all the dissolved gold. He made pink.
Yeah. So glass-making techniques throughout history have been super well-kept secrets. Because if you knew how to make glass, it was a very precious commodity, and you could make a ton of money as long as nobody else knew how to do it. From him writing down those recipes, we have a lot of information that we would not otherwise have, because nobody else wrote these things down.
Thanks, Venice.
And that's actually a barrier to understanding how well certain sciences and technologies were known in the ancient world too, because trade secrets were a thing.
Yeah. So he wasn't the first to make colored glass by a long shot, but he was, again, the first we know who wrote down the recipes for what kind of minerals and oxides created which color, including figuring out that manganese dioxide removed the green tint and so created a clear glass. Romans were making clear glass like AD 100-ish, but there was a few kinds of glass that the Romans knew how to make that were kind of lost for a long time, including pink glass, which is made with gold, that weren't discovered again for a really long time. So it wasn't 100% clear to me through my research, but I don't think that he knew that clear glass was possible again. He figured he just had discovered this cool new thing that he knew how to do, and he wrote it down, which is so important.
The only one I know is the gold, because you told me that one.
Yeah, and so all kinds of different recipes, cobalt and zinc and lead and all kinds of good things that are very toxic, and I breathe in every day.
So maybe our listeners are not all familiar with why this is of importance to you.
Oh yeah, I melt glass all day. I'm a lamp worker. I make beads and sculptures and sell them to my fellow nerds who enjoy recreated historical beads.
This would be a prime opportunity for you to plug your Etsy store.
noblewhimsical.etsy.com. You can buy Norse beads or modern beads. I make adorable animals for Christmas ornaments.
Following in the noble tradition of algebra.
Yeah. So
Literally noble tradition.
Yeah, as soon as I said it.
Oh, sorry. I'm just going to pick up on that.
So he did tons and tons of really cool stuff. All kinds of astronomy and trying to come up with ways to create scorpions in the lab. But yeah, 46 recipes for different colored glass. That's what I was really interested in.
So are we going to ever, color our own glass in the backyard?
No.
That sounds
dangerous.
like a recipe for brain melting.
Just please don't do fire gilding.
Yeah, I don't want to be involved with that much mercury.
We've traveled the length and breadth of the ancient world in this episode. What are we talking about next episode, Ashlyn?
You may remember from the intro.
You may remember from the intro, but why don't you tell us again?
Next show is going to be our live from Skepticamp episode, and each of us once again is going to bring a quiz for our fellow panelists, and we're also probably going to involve the audience, and we are going to test our wits against one another.
Sounds like fun. Thanks for listening, everybody. Good night.
Good night.
Life, the Universe, and Everything Else is produced by Ashlyn Noble and Jem Newman. If you want to support the show, the best way to do that is with a review on Apple Podcasts or Stitcher, or by sharing an episode with a friend. Original music is produced by Ian James, and this episode was edited by Jem Newman.
Life. Don't talk to me about life.
Opportunistic lesbianism. Woo! Woo!
Don't worry, that's not going to make the cut.
You're not going to put opportunistic lesbianism in the outtakes?
Sure, but sans context.
Anyway.
A compass, that's the thing you put the pencil in to draw a circle, right?
Yes.
You ruined it!
Did I do it again?
Of course you did, because you have the exact same sense of humor.
This time he controls the edits, therefore he controls the jokes.
The leaf doesn't
I didn't realize that was the sharp end.
Oh, God. Ow, are you okay?
How I learned to use a compass was Mr. Warwick's grade 5 classes, where he would take us out to Kings Park, give us a compass, and go back to the school. In the snow.
That sounds like child endangerment.
It was a different time.
You magnetize the needle by stroking it against the magnetizing material.
Always in the same direction.
Stroke in a single direction, that's right, not back and forth. It'll probably take several dozen strokes. Try, like 25 or 50.
Make sure it's nice and lubed up.
I was just going to say, you need to stop saying the word stroke right now.
From 0, we're going to move on to Gem's 10. Laura?
Aww.
See, now if I say it, it'll sound like I'm just...
See, we have the same sense of humor. Now you have to be as suave as me.
No, that's never going to happen.
Step it up, Newman. She wants me to dig a large fire pit in the backyard so she can do larger pieces.
No, I don't want you to dig a pit. I want to get... It's called a glory hole.
Oh, come on.
I was trying not to say that out loud.
I did not come up with the name. It's not a pit, though. It's like up on it. It's like a giant crucible, except it's not in a crucible. It's very hot, and you can melt lots of glass at once.
Is it like do you make it like out of cinder blocks or something? Or like, is it kind of like an outdoor kiln?
Most people just buy them prefab.
Oh, okay.
Yeah, we can't
steel
make
and
this.
Oh, okay.
propane and, yeah.
It's a giant thing that goes in the backyard,
It's
though.
really, really hot, yeah.
What could you possibly be talking about?
Music is a lot like love, it's all a feeling, and it fills the room from the floor to the ceiling. I see miracles all around me, stop and look around, it's all astounding. Water, fire, air and dirt, everyday magnets, how do they work? And I don't want to talk to a scientist, cause straight up magic is what this is.